I guess we're live, Nick. Welcome, everyone. This is Shirley of Angel Hack, the organizing team of the Hello Future Hackathons. And we're excited to have you here for our first workshop leading up to the Hedera Hello Future Apex Hackathon 2026, our biggest Hedera hackathon yet, with a prize pool of 250,000 USD. This Neuron workshop comes before the hackathon officially opens, as we want you to have ample time to tackle Neuron's bounty statement in the Hedera Apex Hackathon. The hackathon will run from February 17 until March 23. And let me just give you a quick sharing about this hackathon, the Apex Hackathon. It brings amazing ecosystem partners together, including Neuron World, AWS, Hashgraph Online, Hyro, and Bonzo. These partnerships help to create more opportunities, resources, and real-world impact for developers. And you know what? This hackathon is designed for everyone, whether you're a new developer, you just started, or you're just getting started, or an experienced builder on Hedera. Apex has a place for you. Yes. Now let me share more about Neuron World. They are one of our official bounty partners in this hackathon. Neuron is a DePIN, or decentralized physical infrastructure network project built entirely on Hedera. It uses Hedera's distributed ledger technology to create a secure and decentralized service network where autonomous devices like AI agents and drones can discover each other, connect, and transact directly. Now, why this workshop? And you might be wondering, why are we hosting this workshop early? As I mentioned a while back, we want to give our participants, like you, ample time to build a solution for Neuron's bounty, because we understand that DePIN is a lot more to intake. Today, Nick will guide you on how to approach and tackle Neuron's bounty challenge in the Hedera Apex Hackathon, so you're well prepared even before the hackathon begins. That gives you almost 6 weeks of building period. So for bounty participation clarification in this hackathon, you might have one common question for me. Can I participate only in Neuron's bounty without joining the main tracks for Apex? Yep, definitely yes. You can focus solely on Neuron's bounty if you like. Of course, you're also welcome to submit to the main tracks of Hedera Apex Hackathon as well. By the way, Neuron's bounty offers 8,000 USD in prizes, so it's a great opportunity to explore. And then, of course, during this session itself, please feel free to ask questions by typing in the live thread, and we'll address them at the end. If your questions come later, that's completely fine. Please fill out the form I'm about to share. We have our technical team behind. Please help me share the link for the AMA form. So yes, fill out this form, and I'm about to share it in the thread right now, so we can document your questions and connect you to Nick and the Neurons team for detailed answer. Now, I'm moving on to the speaker introduction, and I'm happy to introduce Nick Sefakis, CTO of Neuron. He's one of the key minds behind Neuron's technology, and this is a great chance to learn directly from him. So yes, over to you, Nick.
Thank you, Charlene. Thank you for having me. I'm very, very excited and honored to be here with you today. Um, let me, I think you introduced Neuron better than I can. But let me just quickly maybe repeat what you just said there. And yes, Nick here from Neuron. What Neuron is, or what this presentation is about today, is a little bit about building DePIN and IoT on edge networks. And we're going to focus a little bit more on the specific challenge, which is a very interesting aviation challenge. More on that soon. Let me tell you a little bit about myself. My background is in, I've started quite academic, and I've spent a lot of time, many years ago, building what's called virtual machines, and these are environments where programming languages run. And in there, I was focusing in tracing paths that programs take and analyzing them and understanding them. Move forward a couple of years later, I entered the DLT space, distributed ledgers, and there was a lot of paths in there too to discover. which were mostly paths in transactions, and a lot of them were monetary transactions, see where monies flow, and all these kind of things. So path has been a bit of a theme in my background, and from that work I met Neuron and the founders, and they were interested in paths too, but these paths, they were in the sky. And I thought, okay, that's where we can do something. So distributed ledgers and path in the sky can do a lot of interesting things. Now let's go a little bit into the agenda of this little presentation. I want you to a little bit understand what Neuron is, what this network does, and of course what the challenge is. So by giving you a little bit of the technicals of what Neuron does, you'll understand the challenge a little bit better. So we're gonna go a little bit about what Neuron is, what it does. In the network, we're gonna look at this case study, which is very particular to today's talk, which is for the sky, which is an application or it's Neuron's poster child, if you like. We're gonna talk a little bit about the SDK that makes all these things running. And then we'll spend some time on the aviation challenge. I will try not to teach, but there is a little bit some information in there that is useful and challenging, and that's why it's called challenge. And then we're going to do a Q&A. I don't think we're going to take more than the hour allocated, so I try to give you Charlene and Luis as much time back as I can. Quick cox tour through the Neuron network. Okay, what is Neuron's network? Yes, it is an edge network, but maybe the easiest thing is to take straight what's on the front page, which is here. Neuron is a gateway. It's a gateway for edge devices or AI agents or peers. Name them what you want, but these are things that live on the edge, and what they want to do is to transact and talk to each other. They want to service each other. They want to sell things to one another. They want to stream data or pay each other, and they want, of course, to resolve their disputes. And this is what Neuron really is. It's a place, it's a gateway that brings all these edge devices, machines, AI agents, sensors, vehicles, AI chats to customers. They can trade their services, their information with each other. And of course, there's services and tools that go around this gateway, if you like, which are explorers and validators and these kind of things. So yes, to the ones that are familiar with these kind of things, yes, this is decentralized physical network infrastructure. And I like to spend a little bit of time to help understand what it takes to build DePIN. Not because we're gonna build one here, but when we go a little bit through the recipe of how to build one, then we understand a little bit what we are dealing here with. So what's the recipe then to build a DePIN? So to make this edge network really sing, what you need to do is to have a way of all these agents, AI, connect to each other. Then once that's done, they need to communicate in some way, and we'll talk about HES and peer-to-peer and all these kinds of things really soon. They need to pay each other. They need to protect each other. And starting with the first point there, straight away, is discover and connect. And you'll see that's a little bit different to communicate. Connect and communicate, they are different things. But let's look at the discover thing. And to discover things in networks generally, you need identities. And in peer-to-peer networks, a lot of these identities are IP addresses and things like that. But we are in the Web3 world, we are discovering each other with modern structures like public keys and EVM addresses and Hedera accounts and these kind of things. So identity and discover in Neuron looks like this. All peers, all AI agents, all edge devices, they do have an identity on a ledger that's coming from a public key, which derives EVM addresses, and the rest of it And once you have an identity, what you do with that identity, you need to be able to share that identity with other peers so that you can tell them that, hey, I'm someone here, that is my identifier. Do you want to talk to me? Do you want to exchange data with me? Do you want us to play this buy-sell game? And to be able to do that, we need to register these identities into business directories, if you like. And here in Neuron, we do that with smart contracts that are on Neuron's network. And these registries, what they really are your yellow pages, or more accurately, white pages. They are business directories where these agents, these edge devices, they list in their identity and their services, and in the hope that other agents will communicate with them and transact, buy, sell their services. And of course, when you have these registries, you have explorers that you build around them. As in our case, we have an explorer.neuron.world, where you can see such identities, such edge devices, such agents to go and connect with them. Now, the interesting thing about these registries is that they start becoming very, very popular, especially in the Ethereum world. You may have come across standards like EEP 3008 and things like that, which are big registries of agents that people now start putting up there for you to be able to find their agents. It is early days, and a lot of agents still don't have much to provide. Yet these edge devices here we have, and we are working towards adhering to the standards. They have a lot to provide. We'll come a little bit through that. So once you're registered and once you are discoverable, what's next to do is to communicate. And communicate is a core thing in Neuron, in the sense that it is a very difficult thing to get right, and it is a very valuable thing to have it work right. Okay, but how does communicate look in Neuron? And the easiest way to explain this, and also to understand a little bit better what Neuron is, other than just a nice yellow pages and some public keys, it's this. Neuron can be really seen. Neuron can be thought of as a virtual wire. Okay, there's the logo of Neuron. Now it's become a wire, and there's some plugs that are connecting things. And the question is, what do we connect there with that virtual wire, right? Of course, it is the peers, the agents, the edge devices, the AI agents, if you like. And all you have is this distant identities that are spread across the world. And what you need is that virtual wire to connect these two. Why would they want to connect? Of course, because they want to buy services from each other and stream data to each other and basically take part in commerce. Establishing this direct connections is also something that is, it's solved in peer-to-peer, yet it's not a very easy thing to do. So, and there's a lot of things involved there, which is IP discovery, signaling, dialing, streaming things, and that's what Neuron's speciality is, in a sense, to make this process a little bit easy and streamlined. I didn't want to say streamlined, but we try to make that virtual connection as easy as possible. And you see in a bit how we do that. We're going to look a little bit at the anatomy of a node. And to look at the anatomy of the node, the best thing is to strip down that wire and expose a little bit the small cables that are inside. Sorry, we strip back the cable and we see the wires that are inside. Yes, there you go. And you can see there that there's three types of cabling in there, wiring in there. One is the peer-to-peer, and for that we use a library called the peer-to-peer from Protocol Labs. And the middle wire there, the blue wire, is HCS. The HCS we know and love. And of course, the last one, which is the payment wire. Now, you will see that there's two different communications ways. One is the peer-to-peer and one is the HES. And the quick way to remember why they are two is that one is a private fast this is a private fast connection. This is a public, still fast, but not something you would stream a lot of data to. And let me explain that a little bit here. You see, when we have peer-to-peer connections, what we do is we connect directly from one buyer device or buyer node to a seller node. And these connections are direct in the sense that there is no Google Cloud or AWS thing in the middle. They are peer-to-peer directly, and they are encrypted communications. They are private, and they are high bandwidth and quite low latency. And this is how our peers communicate. And some people might say, well, why don't you just communicate with HES? You will encrypt everything there and all these kind of things. But the reality is that these are really high bandwidth connections. You would not use consensus services, for instance, to stream a video. You can use consensus services to audit all these kind of things, but for some things you really need high bandwidth connections. And in the AI era, it has started with AI saying little things to each other, but now that the context windows have increased, they want to say more and more and more things, which brings us a little bit to HES. So how does Neuron then use HES? And I believe that we are using the Hedera consensus service in a very novel and interesting way. And HES has become very, very useful in doing that. What we do with with HES is we use it for signaling. So in peer-to-peer, if you have tried to set up a peer-to-peer network, you need something called a signaling server for peers to talk to each other before they connect. And the signaling server is usually a centralized thing, and being here in this nice DLT, decentralized world, we wanted to decentralize that, and we do that by using HES. And what we do is that we define for each node, our specification defines that each node needs to have 3 topics, and these topics are coming a little bit from a Linux background. They need to be called standard out, standard error, and standard input topic. So what is the standard out topic of a node? Is the place that a node is exposing information about itself to the rest of the world. Think of it as your public console.out. And what you would put in there is things like liveness information. I'm heart beating, my node is up, my node is ready, or is about to boot, or booting down, all these kind of things. Error topic is similar to out topic. The only difference is that you would there tell the world that you have a problem with something, that you're going down, or you're going to be unavailable, or something bad has happened. That's the error topic. The input topic, on the other hand, is something that allows other peers to talk to you, to send you messages before and during peer-to-peer connections. And we use that topic to also enable the peer-to-peer connection. And the way we do that is by using this topic to exchange IP addresses. As we said, we don't want to share IP addresses, in the wild. There is a mechanism here we have built to allow people to share their IP addresses so that they can directly connect. And if you are a little bit interested in how that works, that's a very simple protocol. A buyer wants something from the seller. He's listening to the Hedera topics. He's listening here to his input topic for any messages. That seller is doing the same thing, is listening to his topic for any messages. And since they're all on ready mode, they're telling that to the world with heartbeats, yeah, we are ready, we are listening. So let's talk via HCS about enabling our services, or make a service request if you want. So the buyer says, hey, I want things from you. Here's my encrypted IP address. I've used your public key to encrypt this. You can take this, decrypt my IP address, and dial me, connect to me directly in a peer-to-peer way. Then a communication channel and a streaming channel is up, and these two guys can stream whatever they want to each other. Now, you can build in that way all sorts of application. You can maybe build Hedera Neuron peer-to-peer IP telephony or video stream, where the seller is a consultant and the buyer is a client, and for every 5 minutes of video consultation, you pay money to the seller. That is enabled by direct connections, but also the HCS part of it is there to validate what is happening in the private channel. We have not created a peer-to-peer IP telephony, and our poster child is something else. Our poster child is an aviation network, and you will soon see how this has anything to do with aviation. The case study is called For the Sky. It is an aviation network where the data seller, the guy that's at the one end of the cable, is a device that hosts a neural node, and the other side is somebody who wants to buy the device's data. That somebody can be another device, not like this one, but some PC or an AI agent or a monitor, a screen that wants to consume this data. And what is this data this device is collecting? In a nutshell, it is aviation data that are produced by airplanes. Airplanes have a small, they have a radio transmitter on the belly, and the radio goes out of the plane into the antenna. The antenna takes the signal, puts it down the virtual neuron wire, and sells it down the wire. And you might think, okay, wait, that's all interesting. I've seen aviation networks; they all do that, right? That's fantastic, no problem. The interesting thing here is, because we are decentralized, because we are peer-to-peer, and because we are not only decentralizing the resources, like this guy, we're also decentralizing the access. And I'll show you in a little bit what that means, decentralizing access. You see here we have the same example, airplane producing a signal from its belly, radio signal. Two guys are receiving the same signal here. Two guys, two antennas, one signal. Now, yes, decentralize the resources, but here's how we decentralize access by laying out these cables, these virtual cables, in interesting ways. Now, if you can see here that this guy here is able to sell to two people. That's fine. That's what a lot of networks do. But on the other hand, this buyer here can buy from two devices. Now, you will see that this is different to what many other aviation networks at least do, because what they do is they decentralize that, but you need to go to a central server to collect this data, and you will see that having control of that central server is a limiting factor in aviation. And here's an example. When you have decentralized access, then you are allowing the aviation world to build networks that are either small or big, and a mix of them, and all at the same time. Why does it matter? And here's two examples. The top example we have here, an airport that really cares about what is happening around his own location. He does not care what is happening. Let's say this is here in the UK. They don't care what's happening in, let's say, Germany. That's too far away. Planes in Germany don't affect this guy here. So they really need to know what's going on here. So what they do is they consume data only from sensors that are around them. And if there is something happening in the aviation world, like a big event, somebody wants to track a celebrity, which is never a fine thing to do, and the servers are getting hot over there, his operations are not affected, because he's really connecting directly to the peers he cares about. On the contrary, there is a network here that wants to buy things for the entire of the UK because they do analytics and this and that. Again, these guys can buy from the peers they want or the entire world, and that's a different operation. So decentralizing access allows you to run different operations. And here's a little bit how this looks like in practice. We have here this guy here who is a data buyer buying from these sensors here around him and consuming the sensors for the operations he cares about. And if you go here now to this guy here, you see that he's buying from the whole of the UK and maybe more because he's a different business. And he also wants aviation data, also direct peer-to-peer. And this guy here is displaying all this aggregated data on a map that's at appforthisguy.com, by the way. But as you can see, these are entirely different operations that are enabled by this network. So conversely, if you want to run a network like that, you don't need to ask anyone but the sensor providers to provide you with the data. I will try to open up that screen again. It doesn't let me. Give me 1 second, fighting a little bit my presentation. Yeah, it doesn't want to play. Let's try that again. Give me 1 second. There you go. No, come on. It doesn't want to do that. So let's do it that way then. The way Neuron allows you to build such networks is by an SDK, a software development kit. What the software development kit really does is hiding away all this nitty-gritty, and we are in the process of writing a formal spec around that SDK, so that you don't even have to rely on our SDK, but build SDKs according to the spec. This is an ongoing process, but it is good for you to know that this is happening as we speak. And the good thing about specifications are that AI can understand them, and it can help developers really to build things when it has things to understand. The SDK, what it really is at the time being, is a Go library that what it does is it includes a lot of Hedera libraries in there, and a lot of peer-to-peer libraries and the rest of it. And what you do is you build programs using that library to consume and to sell streams. And the way we have done the SDK that far is by allowing you to extend it, write wrappers around it. The streams that you're consuming are very low level. If you want to have higher level access to the SDK, you can write wrappers around it for WebSockets and all sorts of things. We even have created a node builder, which is a visual way of interacting with the SDK. But let me quickly give you the anatomy of a program before we go into the for this guy challenge, the Neuron challenge that is very relevant to this hackathon. You will find that all you need to do in with the SDK is you need to fill up 4 places in a function. And these 4 places, what they really are, is 2 places for sellers and 2 places for buyers. And what these 2 places are really is, one place is what are you streaming peer-to-peer, and the other place is what are you sending via HCS. It really is as simple as that. And now is the interesting time about the For This Guy challenge and how this relates to that challenge. The For This Guy MLAT challenge is a challenge that will allow you to connect to many aviation sensors. We have hundreds deployed at the moment, and it will allow you to connect to them and consume the data using our SDK. And you don't even have to write that step. We wrote it out for you, and you'll see that it's very little, maybe 150 lines of code. And what it does, it really connects to a few buyers and connects to a few sellers, which are sensors, and consumes their data. And that data just ends up in your output. So you connect to 5 sensors, you get a lot of output. You connect to hundreds of sensors, you get a lot of output in your SDD out, in your console out. Sorry. It is there in GitHub. Download it. It is pre-built for you to more or less click a button and start seeing messages going into your stream. Now, the challenge is what they do with these messages. What does Neuron ask you to do with the messages that come into your stream? And let me give you a little bit of background of what is happening with all the sensors and the airplane streaming data out. So yes, as we said, airplane has radio, and radio sends signals to these devices that have a neuron node in there, and it's picked up by them and then sent to the buyer, that little program, program that you can download. And the interesting thing is that a lot of planes, what they do, they have a GPS receiver on their on board, and they know their own location. So, and what they do is they say, hey, my registration number is 1234 and my location is XYZ, and they send you that information. And a lot of aviation networks, this is what they do. They take that information that this guy is telling them, collect it in here, and display that on the screen. That's all nice and fine. The problem is that a lot of times that GPS that is on board either got jumped because it flew over a area where jammers are active. And the problem is that when these things jumped, they may stay jumped for the rest of the flight. Even if they get out of the jumped area, the GPS is becoming more or less useless for a very long time. The GPS doesn't work. Some of them don't have GPS on board. The only thing they do is they only stream out their registration plate. And some of them have a broken GPS completely, and some of them don't have GPS at all. And that's normal in aviation too. And the challenge here is really, can you detect the airplanes that don't tell you where they are? They only tell you, this is my registration, and they tell you another piece of information, which is something very useful. They tell you their altitude, tell you my name is this, and I'm flying this high, but I'm not telling you what the XY coordinate is. And the way to do that is to have sensors of incredibly high quality, which Neuron is having in its network at the moment. There is ways to do that with lower quality sensors, but it is way more difficult and way more tricky. So the algorithm that we use to detect a plane's location when it doesn't want to, or it can't tell us what its XY coordinate is by using a mathematical tool called the time difference of arrival. And I don't want to go too much into teaching, but it's a little bit to get you into the mood of what is expected with these signals you're getting. And this is how it goes. When a plane transmits a signal, it doesn't know what time it transmitted it, but the known here is that the signal is traveling from belly plane to sensor at the speed of light. And a very easy way to remember speed of light is about 1 foot per nanosecond. It's not entirely correct, but it's easy to visualize it like this. And so there's a certain time it takes to come from here to here. And the seller here, that device, is time stamping the time that the signal has arrived. So that's the arrival part. And then it gives that stuff to the buyer. The better this thing can timestamp, the easier time you have. And let me tell you something, the sensors that we run at the moment, really, really, really good at timestamping, and that makes sensors expensive. Now, of course, you cannot do anything with a sensor, right? With one sensor, you cannot calculate anything. Let's see, can we calculate something with two sensors then, right? Two sensors, and something here is sending a signal. Now, if we play this time difference of arrival game, and if we figure out that the difference between these two timestamps is 0, then we can start deducing some things. We can start saying something about the location of that thing. So since the difference between these two things is the same, sorry, is 0, it must be that these distances here are the same. And therefore, the aircraft must be somewhere along that line here. It must be somewhere around here, because from here to here is the same distance to travel that signal. From here to here, the same. Here to here, it's different. And here to here, it's different. So when you look at these things, then you know that you need to satisfy this equation, and then you can start deducing things about the location. So let's look at the case where the second sensor cut the signal, timestamp the signal a bit earlier than this sensor. So what it means is, yes, it is closer to that one, but again, we know that now the location is to satisfy that that time of difference of arrival. You know that it may be the location is maybe somewhere around that parabola. Because the two arrows, the relation between the two is the same across that line here. And of course, while you cannot figure out much of location here, you're getting closer. And the teaching here is the more sensors you put, the closer you get. Of course, that's getting very, very difficult. And let me show you a little bit how it looks like when you have more sensors. And spoiler alert, you need at least 3 or 4 sensors to be able to localize a aircraft. Either that or a lot of other knowledge, cheating allowed. Have a look at this one. So this is a nice tool here, and I'll share it in the slides. That helps you a little bit understand how difficult it is actually to do that. There are 4 sensors here on that plane, and this aircraft, if it beamed the location here in the center where all the distances are the same, yes, of course, everything here intersects in that center, and you can find it like that. Now, when it's somewhere like this, for instance, you see things are getting very, very tricky. The multilateration game is a game of trying to find where things really where they have local minima and maxima. And it is a search game, because to find that location here is not trivial, because you need to search around the space, and you may look at this place and okay, that sounds like a good location, and then get it wrong and thinking that you got it right. And this is really the challenge here. There is a mathsy part, which is running a solver, something that produces a solution, which is a function, if you like, that you input with all the sensor locations and all this and the signal you got and the timestamps of the signal you got for the plane, and that solver will tell you the location of the plane, and it will tell you what error margin you have. But for some of the solvers, not all of them, but for some of the solvers, you really need to provide it also with a guess. So, and the game is a bit of hot and cold, and you tell, look, is it here? And I'll tell you, yeah, it's here with such certainty. So the better you are guessing, the better that little solver does it. And I'll share some links in a bit. There's plenty of the solvers out there. Wikipedia can tell you a lot about that. While all that stuff sounds really tricky, that's not the tricky part. The solvers do solve these things just fine. The tricky part is, sorry, maybe I'm going too naive there. It is tricky, but it's not a unknown problem. So there are solutions there. The tricky bit is, if you ask me, to do all this plumbing. how to connect all these things together so that this solver there starts doing its work. And what I mean by that is getting data from the network, find peers on the Hedera register we have, make them connect, consume the data, wrap the data around whatever packaging you need to, put similar data together, because these solvers, they need the data from one emission, so that you group them together so that you can check the timestamps and do this time difference of arrival. And then all the difficult bits are estimating the quality of that and getting straight lines on the map, of course. And we do multilateration here just fine, and we get straight lines here, as you can see, and some lines here are incredibly jittery. And the reason this is happening is because of other difficulties like sensor geometry. Sensor geometry means that if you have something that's flying inside a circle of sensors, if you like, things are easy, but when it flies outside it, it gets jittery and it's difficult. It's things that you'll have to deal with when you do this kind of things. Getting perfection is not possible, but getting close to it is quite possible, and is part of the challenge. And as I said, we are happy you try different things. Cheat, if you like. When we say cheat, we don't say cheat the challenge, but try to be clever about these algorithms. What a lot of people do is they trade some future. Do you know something about the future in this? What's going to happen, so that you can deduce something about the present, or can you say something about the past, so that you have better presence about better guesses about now? For instance, if you know that this plane has this capability, and you could resolve its location 3 seconds ago to a very high degree with very small error, then this is telling you something about the guess you can apply for the next estimation. So no, don't cheat the challenge, but try to consume as much of knowledge you can during this part. It is required to do stream processing, so we want live things to happen. Of course, you can work your own solutions on the recorded stuff, but it needs to be a streamlined solution. So do show live tracks on a map. Do that. You are allowed to use MLAT data in novel ways. For instance, some interesting things are statistics about planes whose GPS is saying one thing and the MLAT is saying another one, or the GPS is broken. Optimize, spend time on that. Do please respect open source licenses when you do that. There's a lot of libraries out there. When you use them, read the licenses, and when you share the code, make sure that you do respect the licenses. That's very, very important. Do use AI as much as you can, and especially, and I'm going to be very frank, 5 years ago, that challenge would be too challenging for somebody who is not in aviation. Today, not that challenging anymore. Don't please spend too much time on graphics. It is an MLAT challenge in the end. We want it to be a little bit of a challenge. There is a lot of time to produce interesting things. So yes, pretty makes sense, but having planes flying straight lines is also very interesting. What do you need from us is that GitHub repository that we share, and you need also credentials to feed into your data consumer, your data buyer. These credentials you will get from us at the start of the hackathon. They are really your private and public keys, and we're going to give you a list of public keys that represent a list of sellers, so that you feed them in that program and it starts producing streams of data straight away. There is a lot of stuff in the literature to read about multilateration and these kind of things. I call them here context fodder, because we know it's good for us to read, but it's also good for AI to consume a little bit of that. And I would say that this resource here, the The first bit here is the one that is telling you how a data frame that is produced by an airplane looks like. And if you look at this, there's a lot of information. What the key takeaways from this ones are, if you want to keep things simple, that each frame, we need the frames that do tell the registration number of the plane. A lot of them have that. And you will be also it's very useful when you use also the frames that do tell you about the altitude of the plane. Because when it comes to multilateration, there is two types of multilateration, actually many types, but one is a 3D multilateration where you want to find the X, Y, and the Z of an airplane. Turns out the Z is very, very difficult, and the Z, they are telling you what it is in many, many cases. So reuse that information so that you don't have to do 3D multilateration, which is a very hard thing to do. You're allowed to do 2.5D multilateration. What that means is they tell you the third dimension, you worry about the second dimension, X, Y. And that makes it also possible to multilaterate with 3 sensors only. The more you have, of course, the better you're off. There's a lot of links here for you to consume. We're going to share this presentation after this talk. And that is concluding a little bit the presentation. So remember, come to our Discord, say hello. We'll share with you the keys by the start of the challenge. Do read about all that. Play a little bit with the bio that is online already in GitHub. Read the README. We will be around to handhold you in Discord throughout that month. We know it is challenging, but we also are aviation nerds ourselves. So we want to be there. We want to see what you're doing. We want to help you. We want to maybe help you innovate if you want. So, and this concludes a little bit my little presentation here. So thank you so much for having me. Any questions you have, Charlene, shoot. I don't know if you're still there. I don't know if I'm connected. Charlene, you're with me? I'm getting here some questions, but I'm not getting, I'm not hearing you. How can people connect to us via Discord? You will follow this link here, which we will share in a bit. And you will be joining the channel. Come there, say hi, say you're for the hackathon, and we'll take it from there. Let me see, any other questions? From Neuron's perspective, I have a question. What are the missing infra layers in the current Hedera DeFi plus AI ecosystem? What are the biggest missing infra layers in the current Hedera DeFi and AI ecosystem? I think Hedera is pretty complete in infra. The Hedera DeFi, this is decentralized finance, is a little bit relevant to Neuron. And what is missing is, I think, a gap that Neuron is filling. Yes, we have the registries, we have blockchains, we have DLTs, but what we don't have is a way to connect each other. You have a way to transact with the blockchains. That infra is there, but you don't have infra to connect and commerce with each other. Now this public keys and private keys, now they become identities and peers in a distributed ledger, and things talk to each other. Another question we have here is, how can devs best use Hedera's fast finality and tiny fees for real autonomous AI agents? This is what we use here with HES because it is cheap. We can use HES for these things, for instance, to discover each other, agents to discover each other. You'll find also a lot of agent tooling in the Hedera ecosystem. You'll see there's another hackathon that's coming in a couple of presentation in a couple of days that will show you how with HES agents can discover each other too. So this is not something we only do, but our partners do as well. How can I leverage Neuron and IoT projects to track air quality and log data to the Hedera blockchain? Currently, the user says we are using HES, and I think you have a very similar problem that we are solving. Yes, you can say things via HES, but once the bandwidth starts increasing, you probably don't want to do that anymore, because HES, while it can take a lot of transactions per second, you will not want to push everything through HES. And therefore, if you want to track air quality and weather, for instance, you better create a peer-to-peer channel in the Neuron way, send that data from the sensor to whoever needs to collect it or buy it, and via HES, you do the auditing part, you do the dispute resolution part. For instance, via the private cabling, you are sending data, and the public cabling, you are sending the hashes of the data you sent. And when there's a dispute, then people can produce the data that they transacted privately, so for a third-party auditor to say, oh, okay, wait a minute, okay, you should have been paid this guy. I have a project for academic certification on Hedera. How hard is it to integrate Neuron with IoT device to verify physical student attendance or identity on chain in real time? Student attendance in real time, that is a very interesting thing. So I would not know how to measure student attendance, being one myself for a very long time. Sorry, Daniel, I don't have a good answer for you. But I think this concludes the queries that I have here on my screen. I don't know if I'm missing something. And let me go back to you, Shalin, and see if you have any questions.
All right. Okay, I'm back. I'm so sorry. There has been a technical glitch. I was there at the back the whole time.
No worries. I read your questions. I have them here. I hope I managed to answer as many as I can.
Yes, you did.
Hello. In the end. Sorry about gents and ladies.
I do believe that our participants have enjoyed it. You have seen the amount of comments that we're getting, and these are all very positive. They're all very happy. And yes, thank you for the wonderful sharing, Nick. You have shared a lot of it. I know that DePIN is not easy, but thank you for sharing it and letting us know how we can do this on a very simple level that everyone can understand. And yes, as you can see, all the comments has mentioned that they love it. They have a lot of questions that you have tackled yourself alone a while ago. And yes, thank you so much for that. All right, now for any one of you who would still want to ask, please put all your questions here. Once again, I will put it on our chat. And then just in case you still need more time to sink it and to digest what you have heard, you have all the time in the world. We have 6 weeks of building from today. So yeah, for you to get started, what I would want you to do is to please join our hackathon. And yes, you can just focus into the building the bounty statement of Neuron. Please scan the QR code on your screen, or I can also help you with this. Oh, okay. I believe that there are some glitches on my end. I'm so sorry for that. But please join the hackathon. And yes, scan the QR code that is right in front of you. After that, everything will go well. I'll be there on Discord right after you join the hackathon. You register for it. You will be directed to Hedera's Discord. And from there on, you will be connected to all of us, including Nick. I promise to get him to you guys if you need him. And then please catch him, as he is part of our partner, and he's also part of our mentors who can help you mentor throughout the time that you need it. But of course, it won't be an everyday mentorship. There will be a specific time for him to talk to you. It could be offline, it could be online. So please tune in to our Discord, and we will give you the timely announcement that you needed. All right, so how will you get started? Please scan the QR code, join the hackathon, join the bounty. And if you have any friends with you who are just starting or doesn't know how to build on Hedera just yet, we have an online live workshop tomorrow that's going to tackle about the introduction of Hedera. So if you are in doubt that, oh, I don't know how to do it on Hedera, or I need some fundamentals, or I need some basics from Hedera, please join our workshop tomorrow. And you can find that once you join the hackathon. It will be concurrently, you'll join Discord concurrently. You will receive non-spammy announcement and updates about the hackathon. Yeah, Nick, would you want to say anything else? I know that you have helped me hold the fort for how long for the FAQ. So thanks so much for that. But if you want to say any closing remarks to our participants, please do so.
Closing remarks is it is not as challenging as you think. It is challenging. Come, invite fellow people to help. Come and get help. Come to Discord. Get the help. Get mentoring. Don't try to do it all yourself. We are here to help, and I think we are here to show to the world that we can do things that were very, very difficult 5 years ago, very easy and cheaply today. So
Yes.
thank you very much for having me.
Thank you, Nick. But there's someone who doesn't want to let you go. We have Nick from LinkedIn. Here's my question. I'm so sorry, Nick. I need to hold you for another minute. Yes. How far away, optimistically, is Neuron from marketplace launch, or at least so we can start building flows?
Putting me on the spot. Thank you for that. What we are doing right now is when we're building the FortiSky network, which is the system that is more or less not only just the demo, but also showing people how to do things. And of course, we want to run that in the aviation space. To have a useful marketplace, you need to have two parties. One is the suppliers, the data producers, and one is the data buyers. We have been very, very successful so far building things in tandem, getting the suppliers, build the suppliers, build a bit of consumers, build a bit of suppliers, a bit of consumers. So right now we have sensors sending data. Of course, we need more and more and more, and we're also getting consumers, airports and things like that to consume data. To have a get-go on the marketplace, you need both sides to be a little bit on level. Right now, our supplier side is a little bit higher than the consumer side. We want both sides to be ready, at least from a software perspective. We want to have the auditing bit ready for it when the disputes arise. The auditing is leveraging things like Hedera, HDs, and stuff like that. So once we have these things ready, we can say, gentlemen, this is how to build the marketplace. This is what works. Go and trade. So we are not too far away from the implementations, but we are taking a little bit of a different approach than we were taking in the beginning, which is SDKs and this and that. And we're building specifications. And that includes specifications for the marketplace so that people can build their own marketplaces. Right now, we have our For the Sky marketplace, and that works fantastically for this use case. But we want people to be able to build marketplaces for their own networks. From a comment above, air quality, right? So how to build a marketplace, and that's not just a bit of SDK and a bit of peer-to-peer. That's a whole spec that will and should take care of that.
Okay, great. Thank you so much for answering that, Nick. And then I just wanted to tackle this. QR code is not showing. I think I can see the QR code. If you see Nick's frame, there's a little QR code on the right top corner. Yeah. So you can try to scan that and it will direct you to our hackathon page. Yep. All right. Yeah, that's a wonderful presentation. Wow. Thanks, Elijah. Nick will be very delighted to know that. Okay. See you again tomorrow, guys. So once again, we have an introduction to Hedera. So if you have any friends who's beginning to code on Hedera and to build on Hedera, please join us tomorrow. And yep, thank you. Right. All right. I think that's it for the session. And I'd like to thank everyone. I'd like to thank Nick for taking time into this workshop and for being here with us and spending time to learn for everyone. So looking forward to have you join us here again tomorrow. Have a good day. Have a good one, everyone.
Thank you very much.